and let's get going here. So as I mentioned, kind of this like type 1 problem is x squared equals 16. And it's a problem where you have to take the square root of both sides to solve it. This is key though. When you take a square root, it's both plus or minus. There's always two solutions. Now, whether you fully understand that or not, or agree with it, or really like we can't get into that. We just have to say like there are two solutions. So when you see this 2 up here, that is what it means by that. There are two solutions.
So, okay, I guess that makes more sense now. So,
Okay, but let that sink in. Like we're gonna do a lot of problems where there's a 2. There are always two solutions.
So whenever there's always two solutions.
Just like, do you remember at some point in the past, 2x minus 5 equals 10? What's the exponent on the 1 or on the x? Guess how many solutions this has?
One
solution. Yeah. So it tells you how many you have. Okay. Now there's a ton of variations on this problem, but the first one is like understand that there are two solutions. When you square 4, you get 16. Excuse me. And when you square negative 4, you also get 16. Does that make sense? Is that clear to you?
Yeah. So, okay. Yeah, that does. Because 4 times 4 is 16. And then if it's the 2 minuses, it's a positive. And then 2 4s is 16.
Yes.
All right.
All right. So I put up on my website a squares and square roots table. I'm going to just send you the link. The reason I'm sending you the link is in the chat here is that like these are the ones that you're supposed to know. These are the ones that like if your instructor says, Zach, what's the square root of 169? You're supposed to be like, oh, that's 13. You really are. Like it's like your multiplication tables. You really are supposed to know these really well. So there's so many of these, square root of 176, square root of 169. There are
there's a lot of them.
There's a lot of them. I show them up to 25. That's probably more than you would need to know, but you should certainly know like what 1 to like 12 squared is for sure. Like those should be very clear. And then the square root of 144 is 12, and the square root of 1 is 1, and everything in between. So if you have time, print it out, just look at it. It may help you on a problem or two. Okay, so the next type of problem you might see, and I didn't see a ton of this, but let's say you get it down to t squared equals 20.
Okay.
And you take the square root of both sides.
Yes.
This is not a perfect square. Do you see that?
Yeah. So
did you talk at all about reducing roots?
Because
we can avoid it.
I don't really think so.
Yeah, I don't think so either. The one example here that I see is it's a prime. So let me, yeah. Okay, so you're not doing this, but what you are doing, let me give you another one here. What you are doing is something like d squared 6 d squared equals 18. Okay, so here the goal is to isolate d squared, which means if you have a 6 out in front, or let's say you're adding 6, you have to undo those steps. Like, what would you do if this was 6d equals 18? You would divide both sides by 6. You're going to do the same thing here. You divide both sides by 6.
And then that would be d squared equals 3.
Yes. Now, this is something that I noticed in your worksheet. You want to write this extra step here, plus or minus the square root of 3.
And then what does that exactly like mean?
Well, that's a more challenging question to answer. I'm going to try here with the number line. So on the bottom here, I'm going to write like this is 0 and this is 1. But on top, I'm going to write the square root. This is the square root of 0, and this is the square root of 1. This is 2, so this is the square root of 4. The square root of 3 is somewhere in the middle.
Is square root of 3 1.5?
No, is not perfectly in the middle.
Um,
The square root of 3. Okay, now I understand your question. Let's better, I think. So 4, the square root of 4 is 2. We know that for sure.
mhm,
2 times 2 equals 4. The square root of 3 is something. I don't know what it is here, but whatever goes here, if you take it and multiply by itself, you get 3. And here's what you're used to. You're used to these are nice numbers.
mhm.
There are many more numbers that are not nice than the ones that are nice.
Yeah.
Okay. Do you have a hallway in your house?
Yeah.
Okay. So if you go to a hallway, or even just if you put out a stick or something, and you say, well, where's the middle? You're like, well, there's the middle.
Mhm.
And then I say, well, where's the middle between here and here? And you would say, well, it's right there. And then I would say, well, where's the middle between those? And you say, well, it's right there. And then we would continue to do this. We would continue to do this. How long can I do that?
You could do that like 3 more times. I'm a little. I mean,
Okay,
I don't.
let me try another example here. Let's go the numbers from 0 to 1. Because this is important here, because this clearly hasn't been like explained in a way where you understand there are so many numbers. The midway point is 0.5. Do you agree with that? And then the midway between these two is 0.25. And then if I go again, it's 0.125.
And then like 0.225.
0.625.
Oh shoot.
What do you notice about this number here?
It's half of what's before.
Right. Now, can I keep having a number?
Yes.
So I like it. I like the notation this way. It's 1/2, then it's 1/4, then it's 1/8, then it's 1/16, then it's 1/32.
And then
How-
1/64.
And how long can I go?
Forever.
Forever. Yes, that's the right answer. So you can, the point is there are an infinite number of numbers between any two numbers, but only these are the nice ones. Like you've lived in a world of math where the answer is always nice,
Mhm.
but there's an infinite number of numbers between square root of 1 and square root of 4, between 1 and 2, and one of them is the square root of 3. Square root of 2 is right there.
So here, wait, could you say that one more time for the square root? So the square root of 3 is in between
1 and 2.
1 and 2.
Because it's between the square root of 1 and the square root of 4.
Okay. Oh, okay. I don't know why. Yeah, that makes sense. Yeah, 1, 2, 3, 4.
So now the next number here is 3, which is the square root of 9.
Mm-hmm.
And there is the square root of 5 and the square root of 6 and the square root of 7 and the square root of 8.
Mm-hmm. And then
And also in there, like, you're not going to like this, but like the square root of 7.1 is in there. And the square root of 8.573 is in there.
Yeah.
There's a lot of things that are in there, but only a few of them work out nicely.
Technically be like an infinite of numbers in between.
Yes.
All right. I guess that makes more sense.
Okay.
So when you have a 3, then that means you're
like let's try another problem here. Let's say 2t squared equals 10. You want to isolate t squared, much like you would isolate t. So you divide both sides by 2. So t squared equals 5. Okay, and then now you take a square root of both sides. So t equals plus or minus the square root of 5. And this is where it's uncomfortable. You want to ask this question: what is the square root of 5? This is the question. The answer is the square root of 5.
So the square root of 5. It wouldn't, like, it can't be 2.5.
No, because 2.5 times 2.5
is like
It's 5.25.
right. So, but you have to make it like a fraction.
Nope, the square root is, and I know this is uncomfortable, that's why we're doing it, spending a lot of time here. The square root of 5 is the square root of 5. That is what it is. You want to assign it a numerical value, but its numerical value is the square root of 5.
So then the square root of 5 is the square root of 5. So if it's like a square root of 7, do I just write it as square root of 7?
Yes.
Okay, so when it's like a not quote unquote like friendly number,
Yes, I like the way you put that.
then it will just be like itself pretty much.
Yes. There's some exceptions, and you've already looked at a few of them, especially in that reference sheet. Square root of 1, that's 1. Square root of 4 is 2.
So
Right.
then my question is, if it's, how is there two solutions to 5? Would it be like t equals positive 5 and negative 5?
Positive square root of 5, negative square root of 5.
Oh, so that's what the plus minus means?
Yes, that means there's two solutions. Now, let's talk about how to actually do this. So our original question was t squared equals, or we got it down to t squared equals 5. And we said one solution is square root of 5. Another solution is negative square root of 5. We're going to substitute those back into the original. So the square root of 5 squared, does that equal question mark 5?
It here,
So
wait.
the
Yeah, it
square,
does,
the
right?
square root and the square undo each other. So x squared square rooted is x. Square root of x squared is x.
So it'll just stay as x. But if it's a square root, so if there's ever squared with a square root, it'll just become x. Or if it's like a y in it, it would become a y.
Yeah, like I'm trying to show you the relationship between them. So when you square the square root, it just becomes 5. Now the other one's a little harder, negative square root of 5 squared. But when you square a negative, it becomes positive.
So then would it be positive 5 equals 0?
Well, no, it's just positive 5 equals
Okay.
5. We're gonna get to the solving, but this has got to be okay.
So okay, I'm confused. So if you have positive 5, wait a second. If it's negative, okay, never mind. I saw that the first one was, it's positive in the seconds.
Okay, so just to continue this thread a little bit, like square root of 1 is friendly. Square root of 4 is friendly. Square root of 2, square root of 3 are not friendly. Square root of 5 is not friendly. Square root of 6 is not friendly. Square root of 7, square root of 9 is. Now you notice I did not write the square root of 8. Do you see that? Square root of 8 is kind of in this other category that I mentioned before. It's reducing roots. But we're not doing that today. So that's what I was trying to like these are friendly. These are not. And then there's everything in between, which is most of them. Most of them are not friendly or they're reduced.
So, okay, 2, 3, 5, 6. So those are the most common non-friendlies.
Well, we could keep going. Like the square root of 10 is not friendly. Square root of 11 isn't friendly, but square root of 12 could be reduced. And we'll talk about that in another, another lesson, like when you're learned a little more.
Okay, cool. So,
but for now, like for the rest of today's lesson, like, can you, even if you don't fully understand it, is it okay if we just, when we ask what is the square root of 5, we just say it's the square root of 5, because the next question is based heavily on that. All right.
Yeah, I understand that.
All right, great. So now let's look at another question here that's based on that.
So,
All right, so this one is kind of like the last one, but there's stuff going on in parentheses here that makes it a little different. But for the moment, let's just presume it's u squared equals 7 for the moment. And if you take the square root of both sides, the answer is plus or minus the square root of 7.
mhm. Because 7 is a what's it called?
It's not friendly.
So then, how do I incorporate the 1 into this?
Okay, so this is called a u substitution. We're not really going to do this, but it's really x plus 1 equals plus or minus 7, square root of 7.
Mhm.
The parentheses are not needed. I'm just going to rewrite it. And you're not going to like this, but just try to go with it for the moment. We're going to subtract 1 from both sides. So your final answer is minus 1 plus or minus the square root of 7. Okay. So here's literally what this means. And you're not going to like this, but it's minus 1 plus the square root of 7, minus 1 minus the square root of 7. And this is also not friendly, but it's like a variation on it.
So then, is that it?
That's it. Yeah, that's your.
Okay.
So let's do another one like this just to kind of like be okay with it.
Yeah.
So let's say it's p plus 2 squared equals 11.
P plus 2 squared equals 11.
We're going to do this one correctly this time. We're going to take the square root of both sides. But when you take the square root of the right-hand side, you have to write plus or minus.
So, okay, so you'll have to write it as just p plus 2 equals plus or minus square root of 11.
Yes.
And it'll be p equals minus 2 plus or minus square root of 11.
Yes. Now this is, let me just add one thing here because it's what's really good way you said it. My preference is always to put it in front. You'll see some students put it over here, teachers. It's way better to put it in front. There are other reasons for it, but now then second point, unfortunately, is that most instructors actually want you to write out both of them. Like what on the left here is compact. This is verbose, and they want you to write it this way for some reason.
Okay.
Like, yeah. Like that's for some reason, like the other way is not accepted, and you're like, why not? You know, that's just the way it is.
Like I was trying to do this where I had it as like plus minus square root of 11 minus 2, for example, like before, and it just made it like a lot more like confusing to go through.
Okay.
Since it's only just switched like that.
Try this one for me, and then I'll give you a small variation on this. I'll mute myself here, but give this a shot, please. Do you need me to scroll up on the notes at all?
I'll just try this one without the notes real quick and just see how I do.
Sounds good.
Wait, I make it square root of 17, correct?
Yeah, it's plus or minus the square root of 17.
Okay, thank you. Did the other ones not have the number on the outside, or the number equals whatever? Did those also not have a square root on it?
Let's go back and look.
Okay, same thing. All right, my bad. I don't know. I'm going crazy, I guess. All right. Q equals. And then, okay, so I got it.
Okay, so your final answer is 3 plus square root 17, 3 minus square root 17.
Yeah.
Okay, can I have you do one more?
Uh-huh.
All right, let's try this. Let's go with x minus 3 squared equals 25.
Okay. Okay, I got it.
All right, what's your final answer here?
X equals 3 minus square root of 25 and x equals 3 plus square root of 25.
Okay, so I was a little deceptive here. What is the square root of 25? Is it friendly or unfriendly?
Oh, it's a friendly. It's 5.
Yes. So when it's friendly,
I'll have to be aware of that.
like while you said what you said is the correct answer, it would be marked wrong because
It's
your
not.
instructor's like, hey, why don't you know this is? And this is yet another reason to put the number in front, 3 plus or minus 5, because it becomes 3 plus 5, 3 minus 5.
Do I? Oh, so I don't actually write it as square root anymore after that?
Not if it's friendly. If it's friendly and you can reduce it, you should reduce it.
And then I can just have it as 8 and minus 2.
Yes. Yes.
So, okay, so when it's a friendly, I still write it out like that, but then I can divide it even more. So then x minus 3 equals plus or minus 5. Then it would be 3 plus 5 equals 8, 3 minus 5 equals negative 2. And those would both be on the x axis. So then I'd make it like 0, 8. Well, I mean 8, 0 and minus 2.
Yeah, you're jumping kind of way ahead, but yes, that is what's happening here.
Okay. All right. I just have like,
And that's good. And that's really good that you're able to do that. Let's do one more here. I'll throw in just a tiny little wrinkle. See if you can get it. Go ahead and give that a try, please.
All right. Wait, okay. I do have a question on this.
Yes.
So am I making it 2y plus 6?
No. So like you want to divide both sides by 2.
Oh, okay.
And that was the tiny little wrinkle is that
By doing that. And then I can also make 36. That's a friendly.
Yeah, so work it out from here and see if you can come up with the right answer.
Okay. Shoot. All right. Now I feel like I spoiled the surprise, but all right. Y minus 3. Okay, minus 3 and 9. I mean, sorry.
All right, you said
Why-
minus 3 and 9.
Yeah. I don't know. I got that one down.
Okay, we're gonna take the square root of both sides. Okay,
Both sides.
so it's y minus 3 equals plus or minus 6. Did you get that far?
Yes.
Okay, so they add 3 to both sides, but again, you put it right in front here. So it's y equals 3 plus or minus 6,
So,
which
I do
is,
have one question.
Yep.
So
for
if I write it, what if I write it as square root 6 instead of just 6, and then like do that step all again?
so that is, yeah,
Incorrect.
if there's a difference, like the only The only number that's the same is 1 and the square root of 1. Everything else is bigger. So
Uh-huh.
like 2 does not equal the square root of 2.
So the square doesn't 2 does not equal the square root of 2 because that okay. Wait, say that one more time. I think that went over my head.
Well, one does equal the square root. So yeah, these are the same.
Yeah.
This is the only, well, that's not true. 0 equals the square root of 0. That's the other
So
one.
if it's the same, I can't just like write it like that.
3 does not equal the square root of 3.
Yeah. Is 1 the only one that actually works like that?
And 0.
And 0.
Yeah, these are the only ones.
Okay. That I guess that actually makes sense. Okay, that like connects it all together.
Great. Okay, so let's move on to some other questions like those that you talk about in solving quadratic equations through factoring. Is that okay?
Yeah.
Or do you want more of these?
I think I'm ready to move on.
Okay.
And then maybe in the last 5 minutes, just like run, like, I don't know, just do like a little summary of everything we did just to make sure.
Sure. We're actually going to start with GCF factoring first, even though it's part 2. This is the first type of factoring that you should learn.
Greatest common factor.
Yes. So your greatest common factor can be a number, it can be a letter, or it could be a number and a letter. I'm pretty sure we covered this, but I'll remind you of these things if it's not clear to you. So when you look at x squared and 5x, they both have an x in it. Would you agree with that?
Mm-hmm.
So you write x on the outside, and then if you're not sure what to write on the inside here, you divide both of these by whatever you put on the outside. So what is x squared divided by x?
X squared divided by x is x.
And 5x divided by x?
-5.
Okay.
Or well, just 5.
Great. Now, do you see also that if you were to multiply in, x times x gets you back to x squared, and x times -5 gets you back to -5x.
So if I have a problem like that, just look at it as like, oh, there's an x in both of them. I can make that a parentheses and put the x on the outside.
Yes.
So then
We're going to do more problems like this, but is it okay up into this step here? Do you follow it? No questions? Yes. Okay. So now off to the side here, I'm going to remind you of something. What is 0 times 5?
0.
Okay, why?
Because 5 times nothing is nothing.
Yeah, if there's a 0 in there, it doesn't matter the position. Now, what is 3 times 0?
0.
And what is 0 times 0?
0.
Okay, so to get 0, let's talk about what's possible. You could have 0 in the first position, the second position, or both positions.
Okay.
Okay. So why did I bring that up? Well, and these words are important. For every variable term. Okay. And that's actually, that's not quite, it should say variable factor, not term. Okay. Set each factor equal to 0. So let me box in your variable terms, or I'm sorry, your factors here. This is a variable term. I'm sorry, a factor, I keep saying the wrong thing. This is a factor also. So you set x equal to 0, and you set x minus 5 equal to 0.
Mm-hmm.
Do you see that on the left, it's already solved for x? Like it's already x equals a number. Like this is already solved. On the right, you need to add 5 to both sides. So x equals
5. So then.
So these are your two answers. X equals 0 and x equals 5.
So and then if I had that x, that graph on the x-axis, I'd mark a dot on 0 and then a mark on 5.
Yes, that's exactly right. 0 and 1, 2, 3, 4, 5. Okay, let's do another one. Let's say y equals 3x squared minus 9x. And we want to set this equal to 0. So the problem you're going to get could be of that form, but this is the form that we're working with right now.
So I can divide this by 3x.
Yes, so you put a 3x on the outside. All right.
And then x minus 3
on the inside. And then you set, and this is very important, the factors, they have to have an x in them. The factors with x equal to 0. So it's 3x equal to 0. And then it's x minus 3 equal to 0. So on the left.
Oh, okay, that makes sense. 3x equals 0, and then x minus 3 equals 0. Okay, that makes sense now.
So you divide both sides by 3, x equals 0. And here you add 3 to both sides, and x equals 3.
Okay. And then make a mark on 0, make a mark on 3.
Yes.
So then what happens if the 0 like equals 0? What if it was 1?
We're going to do an example like that right now. So let's say the problem is 2x squared minus 8 equals 0. What is the GCF?
2.
So this becomes x squared minus 4 equals 0.
Mhm.
I misspoke almost every time I said it, but does this have an x in it?
No.
So you don't do anything with it. Let's go back. Did this have an x in it?
No.
Yes.
Oh my God, what am I? Yes, it does.
Let's go back and look at this one. Did this have an x in it?
Yes, that does have an x in it.
Okay, if it's got an x, you set it equal to 0. There is no x here. So just ignore it.
Okay. So then would I just write x squared minus 4 equals 0?
Yes. Now notice this problem is like the ones we started with. You add 4 to both sides. Now what's the next step?
You have to make that square root of 4.
Plus or minus the square root of 4.
And then that would be.
Is it friendly or not?
Yes, 2. So then it would be 2 or minus 2.
Yes.
So then can I just leave it as x equals plus minus 2? Or do
Yes.
I
For me, it's fine. Ask your instructor what they want.
Okay.
All right, let's try another one here. This one's bad. Let's go x cubed minus x squared. Actually, that's not fair to you. No, that is okay. Let's set that equal to 0.
I guess you can have 2x squared. So like 2 x's in both.
So here's let me give you some possibilities that I heard, and you tell me what is correct. Any of these what you meant here?
Yeah.
Which one?
I meant oh wait,
Oh,
it just disappeared on my screen.
Wow, that's weird. I'm really sorry about that. I don't know why that happened.
No, that's fine.
Okay. Well, let me just jump to it. It's x squared.
Yeah, that's what I meant.
So what goes in here and what goes in here?
It would just be x minus 0, I'm assuming.
So multiply this in. X squared times x is definitely x cubed. X times
1.
So we're going to change that to
squared.
I want to change that to 1. Okay, now for each term that has an x in it, you set it equal to 0. Is this okay?
Yeah.
All right. Now the one on the right, add 1, so x equals 1. Yay, got it.
Hmm.
What do you do on the left?
Um.
Let's go back here. What did you do from this line to the next line?
Oh, I made it plus minus and squared.
Square root. You take the square root of both sides. So let me help you out here. Remember PEMDAS?
Yes, faintly.
Okay, so you undo addition with subtraction, you undo multiplication with division, and vice versa, right?
Hmm.
This is like they lied to you. There's more than this. You undo squares with square roots. So you undo a square with a square root.
And then it cuts each other out.
Yes. So what is the square root of 0?
Square root of 0 is 0.
Yes. Now, what do you think about this? Do you have an opinion on whether this is good, bad, indifferent?
I mean, I guess you could just keep it as that because 0.
So 0 is neither positive nor negative. It's the only one, which means this is not correct. It's usually written as 0 though.
Okay, so all I have to do for that one would just be write x equals 0 because
And x equals
1.
Yes.
So I circle both of those as my answer, but
They're
then
both your answer.
and then 0 is like the end of my answer chain for that.
Yes. Now there's a small like little thing here that you remember I said earlier, I said this tells you the number of solutions.
Uh-huh.
How many solutions are there supposed to be?
Well, that one has 3 solutions.
So there should be 3 solutions. You're supposed to say, Matthew, I can count. There's 1 and there's 2. Where's the third?
Would it just be x squared equals 0 right there?
The third is 0. It's what's called a double root.
A double root.
Remember how I always tell you there's always exceptions, and the more
Uh-huh.
the curtain gets pulled back and you're like, oh yeah, I didn't realize that. They're both solutions, but they're the same. So you only write them one time.
Okay. So then would it always be a double root like that if it's a like x3 or
No, it just happened to be in this problem.
okay, sweet.
Don't get that out of your short-term memory. Let's go move on to.
Don't worry, it'll be right out.
Okay, so let's do this one. You have enough knowledge to try this one on your own. I will obviously help, but take 60 seconds and see if you can work that one out on your own, please.
Will do. Okay, wait, I have a question.
Okay, go ahead.
So once you get to 2x equals 0 and x plus 4 equals 0, do you have to subtract over the 4?
Hopefully this is key. You have to write each of these separately equal to 0. Did you do that?
That's what I have right now.
They're totally separate problems. So you divide by 2, and then you subtract 4 from both sides.
Okay. All right, that makes more sense. But then
that's your answer.
Divide by 2 because it's 2x.
Say that again.
So how do you know to divide that one?
The 2 is multiplying the x.
So the 2 is multiplying the, okay. So whenever, even if it was like 40x equals 0, you divide it by 40.
Yeah, let's look at something together here. X plus 2, x minus 2, x divided by 2, and 2x. Let's just say these equal 1 in all cases. How do you undo this 2 in the first line?
You have to subtract 2.
Okay, because it's adding.
Yeah.
How do you undo subtraction by 2?
You gotta add 2.
How do you divide by 2? How do you,
Multiply.
so notice in every example here, and here you divide.
Okay, that makes sense.
They're undoing each other. Now, last one here. How do you undo a square?
I guess you have to square it, right?
Square root. This is a square. You undo it with a square root.
Square root.
If you're dividing, you undo it with multiplication. If you're squaring, you undo it with square roots.
All right.
It's the same idea. If you're multiplying, you undo it with division. If I give you the square root of x, this time it's a square root, you undo it with a square. They undo each other.
Okay, that makes more sense for the 0, 1. So if you square it like that, then you'd have to square it by 2, right?
Yes. So like we actually do this all day long, like undoing things. Like you open a door and then hopefully you close the door. You turn on the light and then you turn off the light. You put socks on, you take socks off. Million examples of this all day long where you're undoing, one undoes the other.
Yeah.
And it can go either direction.
Okay. That I get, and then it's like logging on to this call and then like logging off this
Exactly. Perfect example.
All right. So then the one up above where it's like that, so it's 2x, you have to divide that one. So then x equals 0, and then x plus 4, you have to subtract that. So then it's
That's right.
x equals minus 4. Then you have to square root. So then x equals square root minus 4. And then that can become negative 2. So then x equals plus minus negative 2.
Which problem are you doing now?
X plus 4 equals 0.
But you already have the answer. It's x equals negative 4. There's no squared here.
Oh, right. Okay. So when there's no squared, I don't have to do that other stuff.
That's right. You only square root when there's a square, just like you only divide when you're multiplying.
All right. That makes a lot more sense. So then for problem 3 right there, I divide 3 by all those. So that would be x.
What? No. Sorry, I got to jump in here. What do you notice about the right-hand side in the first 2 problems? This is called the right-hand side.
It equals 0.
Is the right-hand side equal to 0 on this problem?
No, it does not.
So how can we make it equal to 0? How can we?
Add 15x.
Yes. So a lot of the math problems you do, like you know how to do something in math. Okay.
Maybe just need that little bit of guidance.
And then we make it back into something that you know.
All right. I guess that that's logical.
So this becomes 3x squared plus 15x equals 0.
All right. And then.
So what is the greatest common factor between both of these?
The greatest common factor in between both of those is 3x.
Okay, now what goes in parentheses?
X plus 5. So then 3x equals 0.
Exactly. And x plus 5 equals 0.
And then that would become, you have to divide 3x by 3. So then x equals 0.
That's right.
And then 5, I have to subtract 5 over. So then x minus 5, and then that's not a friendly number. But then if it's squared, I keep going by making
right,
it.
but it's not squared, so you're stopping here.
Okay, so it has to be squared in that exact part and not in the like original equation.
Yes.
Okay.
Okay, so you said with a few minutes left to go back and review some of the earlier problems. Let's do that with the time we have remaining. I want you to solve for t.
Okay. Okay, I think I got it.
What are your final answers?
T equals or 9. And then t equals square root of like 3. I don't know. I was
Okay.
just a little
Yeah.
confused on it.
All right. So let's just say I gave you a different problem. I said, what if 6t equals 54, what would you do to solve for t?
Divide 6.
Okay. So do the same thing here. What does t squared equal?
T squared equals to 9.
Okay.
Oh,
How,
and then it's squared right there. So then
how do you undo a square root?
you have to it's I know what I have to do. I'm trying to think of the word. You have to, it's
Scroll up
it's
here.
not multiply, it's
You undo a square with a square root.
with a square root.
You undo a square root with a square.
Oh, right. Okay, yeah. So you have to use a square root in order to get rid of it. So then you'll have like, could you scroll back down to that one, please?
Sure. Yeah.
Thank you. T squared equals 9. Then that would give you square root t equals
No,
square root.
When you undo a square root, when you undo a square root, the square goes away.
So then t equals plus minus 9, and then that 9 could be 3, so then plus minus 3.
Yes.
And then that would be the answer.
That's the answer. Yeah.
Equals minus 3 or plus 3.
Yes.
All right.
That's pretty much it for today. This is one of those times it's probably really good to review the video if you can, in the next two or 3 days and work out some of the problems. One of the nice things is we do a lot of problems, so you have a lot there to work from.
All right.
All
Well,
right.
thank you for the lesson. And
Yeah, you're welcome. Thanks for scheduling, and I'll see you next time.
all right. See ya.
Have a great night. Bye now.
You too.